Okay, so hi everyone, my name is Dilpreet and I am your instructor for this workshop on Introduction to TensorFlow. So let's take a look at what we are going to cover today. So the first thing is we are going to take a look at what is TensorFlow and why do we use it. And next thing, we are going to look at how we can install TensorFlow on our local systems, and also on how to use Google Colab to run our TensorFlow in the cloud. And then we are going to take a look at what difference does using GPU over CPU makes. And then we are going to take a look at computational graphs that are available in TensorFlow. And then we are going to take a look at the differences between version 1.0 and 2.0. And then we are going to take a look at what are variables in TensorFlow and some basic operations in TensorFlow. And later we'll be doing a very simple regression example. And that example will be like really simple. For example, we'll be having a single variable and getting a output of single variable. So let's get started. So what is TensorFlow? Well, TensorFlow consists of two words. First one is tensor and the second one is flow. So you can think of a tensor as a matrix. And I will later on explain what exactly or what are the different types of tensor that are available with us on TensorFlow. For now, just think of tensors as matrices with some data points in them. And flow is basically a graph. So what TensorFlow does is it creates a graph of all the operations and then passes your tensors through those graphs and gives you the results. So TensorFlow actually sits between your system. So for example, if you have your system, then what TensorFlow does is it's like a layer on your machine. And on that layer, you can either build your model or run it in any other language. For example, if you build your model in Python, you can always run that model in any other language such as C++ or even JavaScript. Okay, so as for why do we use it? Well, the most obvious reason would be because we have so that we can run it on different platforms. Like if you're building it in Python, you might not be able to run it on C++ or C or any other language. But if we are using TensorFlow, that is possible. So TensorFlow allows us to run our machine learning models independently on any kind of platform. And second one is the GPUs and TPUs capabilities. TensorFlow actually allows us to fully utilize our GPUs and TPUs. And for example, if you are building the machine learning model using pure Python, you would not be able to completely utilize the GPUs because firstly, there are not many libraries available that allow you to do that. And secondly, even if you try to build your own library that does that, like that allows you to utilize your GPUs, it might not be as good as TensorFlow. And the third reason would be that TensorFlow actually has a really good API called Keras that allows you to build your models really fast. So like if you are building a model in Python, it would take a lot of time, but if you are building that same model using Keras, it might take half the time. And these are the reasons why we actually use TensorFlow instead of actually building those models in any programming language. So over here, we have some examples on what you can do with TensorFlow. So as you can see, there are several examples such as you can build a posture, it allows you to maintain your posture, like it actually, like it monitors your attention span and finds out whether you are sitting in the right position or not. And similar to these, there are several others such as this one, which is actually music classification. And there are several more projects that you can build, and you can actually they actually have these links available with them just so that you can take a look at how they built it. So TensorFlow has a lot of things that you can like take help from. And one of the most useful tools of TensorFlow would be TensorBoard that allows you to visualize your models and your data. So right now you might not think that it's that useful, but as you get deep into TensorFlow, you will find it really helpful. Okay, so the next part is these. Other than TensorFlow, we also have some other alternatives to TensorFlow, such as MXNet, Torch, or Theano. And but I have only used MXNet and Torch, and in my opinion, MXNet is better than Torch. And but TensorFlow 2.0 is better than MXNet. But if we are comparing the older version of TensorFlow, that is version 1.0, I think MXNet used to be better than TensorFlow, but since the release of TensorFlow 2.0 this year, TensorFlow has improved a lot. So right now, TensorFlow is the best platform that allows you to build your machine learning models. Okay, so now let's take a look at how we can install TensorFlow on our own systems. So what I'm going to do is I'm going to open up a command prompt. So now there are two ways that we can install this. First one is using a pip installation, and the second one is using the Conda installation. But I would not recommend that you use the pip installation, because uh, while we are using the pip installation, we actually have to manage all the dependencies ourselves, but Conda does that all on its own. And the second thing would be that I would recommend that you actually actually install these libraries in a separate environment. The reason being that if you install it in your root environment, you might face some problems with some other libraries. So what I'm going to do is I'm going to create a new Anaconda environment. So I'm going to say Conda create slash -n, then the name of the environment. For example, I'm going to say, I'm going to keep the name as TensorFlow. So now if I press enter, it will actually create a environment called TensorFlow, but I already have an environment named TensorFlow, so I'm going to say no. But if you say yes, it will automatically install all the dependencies in the environment, and it will have a basic version of Python running in it. So I'm going to say no. But once you are done installing, what you need to do is you need to actually activate your environment. So I'm going to say activate, then the name of the environment. So that is TensorFlow. So once your environment is activated, what you can do is you can directly install TensorFlow using these two commands. For example, if you want to install the CPU version, you can just type conda install -c Anaconda TensorFlow. Otherwise, you can add a hyphen and then GPU at the end if you want to install the GPU version. So I'm going to say conda install /c Anaconda. This is the command for installing the CPU version. If you want to install GPU, then you can put another hyphen and then type GPU. And if you run this command, it will look at all the dependencies that need to be installed on your system, and then automatically collect those dependencies from different GitHub repositories, and it will actually ask you whether you want to install them or not. So if you press yes, then all the dependencies will be installed on your PCs, but this will take a lot of time, and I already have installed TensorFlow on my PC, so I'm going to say no. But after you say yes, then all the steps should be pretty straightforward, and you would not actually have to do anything after this. So I'm going to say no, and because everything after this is pretty simple. So once you have installed TensorFlow on your PC, what you need to do is you need to actually open up a Jupyter notebook or even a Spider code editor. But before you do that, like when you open a new terminal, what you usually have is that you are in a root directory of your environment. So first let me deactivate my environment. So when you open up a new command prompt, this is where you are, but right now you are not in the environment in which you install TensorFlow. So first you need to activate your TensorFlow environment. So I'm going to say activate TensorFlow. Activate then the name of your environment, that is. So after you have activated your environment, you can directly type Jupyter Notebook. And if you run this command, it will start a Jupyter Notebook. But if you are on a Linux or a Mac, what you need to do is you need to actually type / then Jupyter Notebook to run your command. So once the Jupyter Notebook has started, what you need to do is you need to open up a new Jupyter Notebook. And this Jupyter Notebook now should be running TensorFlow, whichever version that you have installed. So to check if TensorFlow is working correctly, what you can do is you can say import TensorFlow. And if you run this, if it works correctly like this, then that means you have correctly installed your TensorFlow on your PC. Okay, so next, I'm going to show you how you can install or how you can use TensorFlow using Google Colab. So to do that, first you need to, you can either go to Google and search for Google Colab, or you can visit this link. So I'm going to open up this link, and so once you open up this link, this is what you should see. And over here, you can either import your files from Google Drive, GitHub, or even upload it from your own PC. So I'm going to create a new notebook. And right now we are actually running our TensorFlow, but there is no accelerator for it. So what that means is that we are actually running the CPU version of our TensorFlow. So to change that, what you can do is you can go to runtime and change runtime settings. And in the hardware accelerator, you can either choose GPU or TPU. But for now, I'm going to use the GPU version. So I'm going to say GPU and then click on save. Now you should be running the GPU version of TensorFlow on your on the Google Colab. So to test if it's working correctly, what you can do is you can say import TensorFlow as TF. And if this if this command works correctly, then that means everything is working fine. But if it doesn't, you can always start another Google Colab notebook, or you can either restart your kernel. So once you have changed the accelerator settings, what you can do is you can say tf dot underscore underscore version. And if you run this command, it will return you the version of TensorFlow that you are using. For example, mine is 2.3.0. And there are some very useful functions that you can use in TensorFlow. For example, if you want to check if your TensorFlow is like it has built-in GPU support or not, what you can do is you can say tf.test is built in with GPU. And if you run this, it will tell you whether the kernel that you're running right now has GPU support or not. For example, if I change my runtime settings to none and run this again, sorry. Okay, so as you can see, we have it returned true because the version that is installed on Google Colab is actually GPU version. So like, for example, if I have GPU version installed, I can automatically use the CPU version, but I might not be able to actually utilize the GPU that is installed on my kernel. So I'm going to revert those changes back into GPU. And if I run the TensorFlow again. Okay, so next what you can do is you can also check the name of the device that you are using. For example, if I say tf.test.GPU device name, and if I run this, it will return me the name of the GPU device that I am using. So it should be GPU 0, by the way. Yeah. So it returned me the name of my GPU device. So other than that, I can also get the names of all the physical devices that I have on my kernel. For example, if I say tf.config.experimental.list physical devices. And this should return me all the names of the devices that I am running on my machine. So next, let us take a look at how much difference does using a CPU over a GPU makes when using TensorFlow. So to do that, I created this function. So what this does is it actually measures the time it takes to perform these three operations. So what I'm doing is I'm going over some time step and multiplying, actually matrix multiplying the matrix that I am passing to this function.